I am Davide Sestili, a postdoctoral researcher at the University of Camerino. And what I want to talk about today is, okay, sorry, I'm using this other microphone right now. So what I would like to talk about today is, I would like to talk about the integration between the blockchain and the IoT, more specifically, what the blockchain can offer to the IoT. And then we will also see some challenges in integrating the blockchain with the IoT and some future directions. So, first of all, I would like to give you an introduction on blockchains and on the related concept of smart contracts. So I did not suppose that all of you know a lot about blockchains and smart contracts. Maybe a lot of you know, but not necessarily all of you. So we will start with the understanding what is a blockchain. So first of all, the concept of blockchain was first described in 2008 by a person or a group of persons. We don't really know who this person or group of persons is, under the pseudonym of Satoshi Nakamoto. And this technology was described as a purely peer-to-peer version of electronic cash. Now, actually, blockchain. Sorry. Oh. Oh yeah, probably because there was the other one speaking before. Okay, so as I was saying, the concept of blockchain was first described by Satoshi Nakamoto, which we don't really know who this person or this group of person is, in 2008, and it was described as a purely peer-to-peer version of electronic cash. Actually, electronic cash was possible even before the advent of blockchain. Online payments were possible even before the advent of blockchain. What is interesting to understand about the blockchain, what was the innovation that they provide, that the blockchain provided, is that it allows people to perform these online payments without having to pass to any central financial authority. You do not need to trust anyone. It's a purely peer-to-peer version of electronic cash. And this was achieved by implementing a distributed ledger in which transactions can be recorded in an ever-growing list of records that are called blocks, which are cryptographically linked to each other. And these blocks can be generated according to the rules of the consensus protocol that the specific blockchain adopts. So, for instance, the most famous blockchain that we know, the Bitcoin blockchain, the consensus protocol adopted is a consensus protocol of the kind of consensus protocols called proof of work consensus protocol. So, just to give you a small example of how this technology works, let's say that we have two users. We have Bob and Alice. We have a blockchain network. And Bob would like to perform a transaction to Alice. Bob would like to give Alice some amount of money. So let's say that he wants to give 5 coins, let's call them coins for now, to Alice. So what he has to do in order to perform this kind of transaction on the blockchain, he has to create a transaction, possibly by signing a transaction with his private key. And then he can send this transaction to the blockchain network, meaning that he can send it to a node of the network, to multiple nodes of the network, and so on. And then some special nodes of the network, which, for instance, in the blockchain, in the Bitcoin blockchain, are called miners, while in other blockchains can be called with other names. Well, these special nodes try to compete. They first check whether the transaction can be performed. They can do basically by looking at their copy of the blockchain, of their list of transactions that are recorded in the blockchain. And by looking at this list of transactions, they can actually understand whether Bob has enough money, for instance, to perform the transaction. And if the check passes, then the nodes of the network can actually compete in order to create a block of transactions. And they compete, for instance, in Bitcoin blockchain by trying to find a special number which is anonymous that, when hashed with other information about the block, produces a value with a number of leading zeros, with a certain number of leading zeros. Now, since multiple miners may do that thing at the same time, so what can happen is that we can have blocks, multiple blocks that are linked to the same last block. However, in the long run, the miners and the nodes of the network will reach an agreement on what is the authoritative chain, what is the real blockchain, by selecting the longest one, or by selecting the one that has the most work done on it. So this is a small description of what a blockchain is, what a proof of work blockchain is. So there are also other kinds of blockchains. And what is interesting to understand about the blockchain is the features that it provides. So, for instance, it provides decentralization, a decentralized platform for doing certain things. So, for instance, the most common thing that we do with blockchain is performing financial transactions, but it's not limited to that. We can do that in a decentralized way, meaning that we do not have to trust a specific central authority to know that the system works. What we have to trust is instead something like a statement. So, for instance, in a proof of work blockchain, the statement that we need to trust is something like the majority of the computational power of the network is not held by any set of colluding entities, or something like that, depending on blockchain, of course. Then it offers data immutability. So it means that when we perform a transaction, and this transaction is included in a block that is going to be part of the blockchain for enough time, then we are quite sure that the transaction will not be deleted. It's not 100% certain, but it's very close to 100% after a certain amount of time, for instance. And then it provides a smart contract execution platform. And we will see right now what is a smart contract, and why this thing is also important for the integration of blockchains with the IoT. So let's talk about these smart contracts. So these things are often described as self-executing contracts, whose lines of code specify in terms of a given agreement. So what it basically means is that we would like to create an agreement, a contract, let's say, between multiple users, and we want this contract to be enacted by someone. We can do that by writing a code that specifies the behavior of this contract. And so the average smart contract looks something like the one that you see in this slide. It looks like a simple program with written in an average programming language. In this case, the programming language that is used in this example is Solidity, which is a programming language for smart contracting. So to understand a little better how it works, we still try to make an example. Let's say that we have an inventor, someone that has a project in mind. So let's say that this person has a project, and he wants this project to be funded. So he needs, for instance, $100,000 in order to fund this project. It's not a lot of money actually for a project, but let's say that he wants this amount of money. So now we have Alice and Bob. that may want to fund that project. However, $100,000 is a lot for them. So let's say that they would like to give him a little bit of money, would like to fund the inventor. However, they would also like to have the guarantee that that if the inventor doesn't reach the amount he specifies with other funders, they want to be reimbursed. So let's say that the inventor may try to propose them to send the money to a third party, and this third party may give the money to the inventor if it reaches the amount specified, as reimburse Alice and Bob. However, they may not trust this third party, and also maybe they do not want to pay commissions for using this third party. So what they propose is to create a smart contract, and put it on the blockchain. So the inventor agrees on that, he creates a smart contract, he puts it on the blockchain, and then Alice and Bob can transact directly with the smart contract and be sure that they can be reimbursed if it doesn't reach the amount specified. So, okay, we have given a very small introduction about blockchains and smart contracts. So now we can talk about the integration of the IoT with the blockchain. We can try to understand what the blockchain and what smart contracts can offer for the IoT. So let's talk about the IoT. Here in IoT applications are often involve a lot of devices. Sometimes they are small power devices, such as sensors, actuators, or smartphones, or many other kind of devices. And these devices require to perform, for instance, some kind of complex interaction among them. Or we may want the data of these devices to be kept in a secure location, let's say. So some of these applications can actually benefit from the features of the blockchain. Since the blockchain provides that immutability, so we can store, for instance, data on it, be quite sure that it's going to be kept there, even when we do not have reason to trust any single central authority for doing that. So it provides that, which is kind of useful for the IoT. It provides transparency because we know how the data is going to be processed by the blockchain. And then blockchain also offers a useful smart contract execution platform where we can write part of the logic of the IoT application. So there are already, in fact, some IoT applications that make use of the blockchain. Some of them are microgrid applications, other are food chain applications. There are also some applications in the health industry. We're going to see something about microgrid application and the food chain. So, for instance, in the microgrid, we have a group of interconnected energy users and producers that use energy, that may produce energy, and that is actually locally generated. So in a microgrid, we do not necessarily need to rely on a national grid, but people can exchange energy that is locally produced. And these things can actually save energy costs for people and even reduce the emissions of pollutants. Because you may use the locally generated energy generated by some, for instance, solar panels or things like that. You do not need to transport energy far away. So, since we are in a situation like that in which multiple users may produce energy, may sell energy, and we are not anymore relying necessarily on a central authority, which could be the authority that governs the national grid, we may use the blockchain, and actually it has been used in blockchain in order to allow users and consumers to sell and buy energy, even thanks to the smart contracts. Now, another example, something that we have actually worked on, is on the food chain. So this project, we worked on a secure traceability system for ensuring the origin of a certain kind of fish, which is Tazara fresh anchovies, which is a valuable fish that is caught in southern Italy. And we did that with the use of blockchain. So basically, we have created certain devices that could allow fishermen to scan, basically to read the information on certain boxes of fishes that these fishermen fills with the fish that they caught. Then, after having read after having read the information on these boxes, then this device will send the information about these boxes. So, for instance, the information about the location in which the fish was caught, and the ID of the box of fish that was read to the blockchain, to a smart contract. Smart contract that can be identify the device that is from this reading, so that we know that it is a valid device for doing such a thing. And then it will store permanently the data on the smart contract. And then anyone, by looking at for instance, at the QR code of the box of fish with a smartphone application, can actually know whether can actually know information about this box of fish. So you can actually know whether it is real Cetera anchovies or whether it is not. So we have talked a little bit about the blockchain. We have talked a little bit about smart contracts. We have seen some examples of applications that involve use of blockchains in the world of the IoT. So, however, it's not everything so easy. So, for instance, there are still some challenges and some future direction that can be taken. So, for instance, the challenges of integrating the IoT and the blockchain are often the ones that you see in this slide. So, for instance, traditional blockchains have very low throughput. What does it mean? It means that we can perform only a very limited amount of transactions per second. And in many IoT applications, we need a lot of transactions to perform. We create a lot of data. We require a lot of data to be processed. So it may not always be feasible to use the blockchain in these kind of applications. Then we have the problem of fees. Actually, when miners or other kind of nodes wants to create a block, tries to create a block in which there are transactions, in order to include certain transactions in the block, well, he may require certain fees to pay. What does it mean? It means that if someone wants to generate a lot of transactions and wants these transactions to be stored in the blockchain, he probably needs to pay a lot of fees that is proportional to the amount of data that's being produced and to the complexity of the elaboration that is going to be performed on the data. And we have latency issues. So we are working with the blockchain. And what often happens is that if you want to if you want to store a transaction on the blockchain, you probably need to wait a lot of time. And these may not be very good for IoT applications when we need real-time elaboration of data. Then there are high hardware requirements, which means that in order to run a node of the blockchain, we probably require the hardware that a lot of IoT devices do not have. So for instance, we may require a lot of computational power, or we may require a lot of storage that not every kind of IoT device possesses. And there is also privacy problems, privacy challenges, let's say, with the integration of the IoT with the blockchain. So for instance, in some IoT applications, such as in some health industry applications, we are dealing with sensitive data, and it's not always that easy to keep sensitive data private in a public blockchain. However, people are still working on these problems, and some solutions already exist. So the majority of solutions to these kind of problems, which the majority of them can be considered the problems of the blockchains, but the majority of these solutions can be grouped into two categories. One category is the layer 1 solutions, and the other one is layer 2 solutions. Layer 1 solutions require the redesign of the underlying blockchain, or the underlying consensus protocol that the blockchain is using. And one of these solutions, for instance, comes under the name of IoT, which implements a distributed ledger, not as a blockchain, but as a different kind of system in which transactions are not ordered into blocks, but are put in a directed acyclic graph. And this kind of distributed ledger allows even low power devices to be nodes of the network, basically. Then we have other solutions, other layer 2 solutions that do not require, for instance, the redesign of the underlying blockchain, but can work on top of the blockchain. And these are called layer 2 solutions. So an interesting layer 2 solution comes under the name of state channels. What state channels actually do is they allow people to perform multiple transactions of chain, to perform a smart contract of chain with and limiting the amount of data that is going to be put on the chain. So we are actually reducing the burden on the blockchain for executing a smart contract. However, recently, a lot of these kind of solutions allow only two-party smart contracts to be executed on chain. Not all of them, the majority of them do. And some of them also actually allow the execution of multi-party smart contracts on chain. However, they still may have some limitations. So, for instance, one solution that we have seen requires people to take turns in order to interact with these off-chain smart contracts. And it's not always the case that we want people to take turns in interacting with smart contracts. And there are also some privacy-preserving methods for distributed ledgers, or even public distributed ledgers, that tend to use zero knowledge proofs and a lot of some solutions already exist, but there is still research work going on in this direction. So, talking about what we actually are doing with my research group at my university, we're actually trying to create a system that allows the execution of multi-party smart contracts for the IoT. We do that by making devices in a sensor layer to send some data, let's say, to an intermediate node layer. This intermediate node layer is going to be responsible for creating, for instance, proofs on the kind of results from the elaboration of this data. And these proofs may be sent to the blockchain only when certain kind of bad behavior happens, or may not be sent at all. And everyone is going to be ensured that the computation being performed correctly, even though the vast majority of these nodes behave incorrectly. And this also allows, for instance, people to execute very complex smart contracts with very limited amount of data to be committed on the blockchain. So this is all, and well, thank you for your attention.
Thank you.
Thank you, Davide.